Okay. So again, just one more day here with graphing polynomials just to make sure we're kind of comfortable with it. All right. So we'll just do, like I said, 2 more examples, and then I'll have you guys try 2, and then we'll get started on the assignment. And it's frozen. There it is. Okay. So we'll just jump right into an example. Y equals, and I'll start with one that's already nice and factored for us here. So x minus 2, x plus 4, quantity squared, and 2 minus x. Okay. So there's our factored polynomial. X minus 2, x plus 4, quantity squared, 2 minus x. Okay. So, again, things we want to find, right? First thing we want to find those zeros of the polynomial. Then we want to evaluate behavior between zeros. All right, which I call the middle behavior. We also want to determine that end behavior. All right. And then lastly, we'll sketch a graph. Okay. On the test, I'm pretty sure that the questions will lead you through these pieces, right? So I'm not just going to throw a polynomial at you and expect you to know my little idiosyncratic way of having us sketch these graphs, right? So I'm not going to be forcing you to memorize, Mr. Widmeyer's method of graphing a polynomial, right? You'll be kind of given a polynomial, you'll be asked to find the zeros, evaluate the behavior between those zeros, you'll be asked to determine the end behavior, to analyze it, whatever, describe it, and then also asked to sketch a graph. So it's not like you'll need to memorize these steps. They'll kind of be asked of you, and then you'll be asked to, graph the polynomial and stuff like that. All right. So, but you'll still need to know what to do, right? And do it accurately, of course, too. So we're going to find those zeros, right? So that just means we're going to take our polynomial, set it equal to 0 here. So, okay. And since it's already factored for us, we can go ahead and just take advantage of that zero product property. And each factor there equal to 0, and then solving, so we get x equals 2 here. This one will also be an x equals 2 as well. Subtract 2 over and divide both sides by -1, it'll still be x equals 2. And then here, to solve this one, well, let's see, I got a square, so I'm going to square root both sides, so it's x plus 4 equals 0, right? When you square root 0, yeah, it's plus or minus 0 technically, but there's no plus or minus 0, it's just 0, so you get x equals -4. Alright, let's see here. So our zeros, there's only 2 of them, but they both occur twice, just in kind of different ways, but they do both occur twice. So let's see here. Our 2 zeros are -4 and 2. So really you can pick any number between that -4 and 2 to kind of help figure out what your end behavior or your middle behavior is going to look like. Again, I like to pick the midpoint, so that would be like -1. Okay, it's halfway between. Again, if you're not sure how to find the midpoint between 2 numbers, add them up, divide by 2. So -4 plus 2, -2, divide by 2, -1. And then we'll evaluate that -1 in here, so it'll be, let's see here, whoops, y equals -1 minus 2 times -1 plus 4 squared times 2 minus -1. And so let's see, we get -3 times 3 squared times 9 times, and then let's see here, 2 minus negative 1 is the same thing as 2 plus positive 1, so it'll be 3. So, ooh, negative 81. Another really big, or really small in this case, y value there. Okay. So there's that mid-behavior point, right? And then the last thing, end behavior. Alright, so as x approaches infinity, f of x approaches something, and as x approaches negative infinity, f of x approaches something. So what is the degree of this particular polynomial? What's the degree here? 4? So it is 4. Okay, it is 4. So it's even. And what's our leading coefficient going to be? Positive or negative? It's going to be negative. Very good. Okay, this x and this x is going to be squared. So it'll be x cubed, right? Positive x cubed because it's a positive x, and that'll be positive. But then that negative x right there is going to make our lead coefficient negative. So we have a negative lead coefficient, and it's an even degree. This means they both either go up or they both go down. In this case, since it's negative lead coefficient, they're both going to go to negative infinity. Okay. And so the last thing here we'll do is just sketch a little graph. So I guess I'll just squeeze that in right here. Alright, so let's see. So again, when it comes to sketching the graph, right, the things I'm looking at my zeros. My zeros, right, the lowest, the farthest left I need to go for my zeros is negative 4. The farthest right I need to go is 2. And then as far as the y coordinates are concerned, I have a point negative 1, comma negative 81 that I need to graph. So what I'm going to do is probably kind of shift things up a bunch, like that. Okay. Leaving myself maybe like, you know, enough room for that 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to count by tens, right? Because we've got to get down to negative 81. I'm going to count by tens here. So I'll say that's 10. And then here on the x-axis, I'll just count by ones, because that's all I need. So negative 10, so on and so forth. Okay. You know, 1, 2, 3. All right, and it's just a matter of plotting those points, right? So now we'll just plot the points. X equals negative 4, and I'll use the different color here so that way it contrasts a little bit. Okay. So there's negative 4. And then x equals 2, it's another 0. And let's see, we have to plot the point negative 1, negative 81. So negative 1, and then let's see, 10, 20, 30, 40, 50, 60, 70, 80, and then just a little bit more, 81. There's our points, and if we just go based off those points and our like typical intuition here, we may be tempted to be like, oh, this is kind of going to look like a parabola, right? We're just going to go like down and back up, right? But that's not the case, right? Because our end behavior here, as x approaches infinity, so I'm going to go to my rightmost point here, like to kind of show, you know, as we go further right from my rightmost point, I know my function has to go down towards negative infinity, so I got to go down. And as I go further left, as x approaches negative infinity, my function also has to go down to negative infinity, so I got to go down. So it's like something like this. I got to go hit this 0, and go back down, hit that, and then back up, and hit that, and there it goes. Okay, so like there's what the graph would look like, something like that. Again, we shouldn't be surprised that this behavior is occurring at those two zeros, right? At the 0 of negative 4 and 2, we shouldn't be surprised by that because they're double roots, right? And again, we recognize when we have those double roots, here we have a very obvious double root because it's squared, all right? So that will result in it kind of coming up and touching and going right back down. And then, but the 2 also ended up being a double root, right? And so again, it came up, touched, and went right back down. So just be careful about trying to connect those things. You know, use that end behavior to help guide you. Okay, all those pieces need to match, right, to be represented. All right, questions on any of that? Easy, easy, easy. All right, we're going to do one more here together, and then I'll have you guys try one on your own. I'm going to try and squeeze it in right here at the bottom. All right. Y equals x to the fourth plus 5x cubed minus 6x squared. Okay. So again, we'll find our zeros. So we'll find, 0 equals x to the fourth plus 5x cubed minus 6x squared. All right. And so, let's see here. Andrew W. All right. How should I proceed from here to find the rest? Find these zeros. I set it equal to 0, but now what should we do?
I factored out x squared.
Factor
the remaining polynomial.
All right. So we factored out x squared. We're left with x squared plus 5x minus 6. Does the remaining polynomial factor?
Yep. X minus 6, x plus 1.
Okay. Ooh, I think it's going to be x plus 6, x minus 1, I think.
Oh, yeah.
Yeah. Okay. That's fine. Yeah, right, yeah. That's fine. Okay. If this thing, bless you, if this quadratic didn't factor, will we assume that that thing doesn't have any zeros then? If this quadratic, right, didn't factor, will we assume that this is not going to give us any zeros then? No, right? Because what other option do we have if it doesn't factor? Quadratic formula. Right. Now again, if you had to use the quadratic formula and it didn't factor, that means you're going to have probably some irrational, zeros. This could be kind of tricky to graph. Again, you just want to try and graph it as best you can, right? You're trying to estimate where that square root's going to be and stuff like that. Okay. But in this case, we don't have to worry about that. It all factors nicely, so you can set each factor equal to 0. And so you get x is 0, x is negative 6, and x is 1. Okay. So let's see here. In order, that would be then negative 6, 0, and a 1. Okay, so again, for that middle behavior here, I like to pick the midpoints. You don't have to pick the midpoints. You can pick any point between, but it helps give a more accurate representation, I feel like, when you use the midpoints. So, midpoint between 0 and 1, 1/2. Fractions. Oh, man. All right. So we'll plug these in and evaluate. So y equals negative 3 to the fourth plus 5 times negative 3 to the third minus 6 times negative 3 squared. Alternatively to plugging the negative 3 into the original polynomial, you can also plug it into the factored form, which I find might be a little bit more palatable, right? Because negative 3 squared, we can just say that's going to be 9, and then negative 3 plus 6 will be 3, and then negative 3 minus 1 will be negative 4. So it might be easier to multiply those three things together instead of having to do negative 3 to the fourth, and then plus 5 times 3, negative 3 to the third, and so on and so forth. So in fact, I'm going to do it that way. So I'm going to say negative 3 squared times negative 3 plus 6, and then times negative 3 minus 1. Okay? And so that yields 9, 3, and negative 4. Alright, so maybe that's a little better. I don't know. So 9 and 3 is 27, times negative 4 is going to be 112? No, 108? I can't do math well. 108. Negative 108. Okay, and so you end up with negative 3 comma negative 108. And then for 1/2, I'm just going to go ahead and do that. So we'll have 1/4 then, because we 1/2 squared, times, let's see here, 1/2 plus 6, 13 halves. And then 1/2 minus 1, that'll be negative 1/2. Alright, so we end up with negative 13 over 16. Okay, just check my math there real quick. Bless you. All the nice weather has brought out the pollen and things, I think. Yes, -13/16. Perfect. All right, so we also have the point then. It's going to squeeze in right here. 1/2 -13/16. Okay, so there's our two middle behavior points. Okay. Here and here. And then lastly, the end behavior. Okay, which I'll maybe put right up here so that way I just have enough room. As x approaches infinity, f of x approaches. Okay, and so let's see here. So, Caitlin, what will be our end behavior here? What is the degree of this polynomial? 4. So, yep, same direction. And so in this case, specifically, positive infinity. You got it. Okay. So there it is. All right. So now let's graph this thing, right? Let's graph this thing. All right. So again, kind of like taking in everything here. I've got some zeros. I need to go from -6 to 1. Okay. And then for my y coordinates, I have a -108 and then -13/16. So again, I don't need to focus too much in quadrant 1 and quadrant 2, right? Quadrant 1 and quadrant 2 won't have too much going on. So I'm going to focus more on quadrant 3 and 4 with my graph here. So when I go to graph, I'll do more something along the lines of this. Alright. Just because it gets so negative there. And we'll plot these zeros. So let's see, we need to go from -6. So let's see, I got to go out 6. So 1, 2, 3, 4, 5, 6. And as far out as 1, so 1, 2, 3, okay. And to get to -108, I'm going to probably just count by tens again here. So I'm going to be a little more. So 10. So there's 100, and there would be -110. This would be -10 there. Okay. So again, you don't have to label all of them if you don't want to. I just label it there for myself, so that way I don't have to keep counting back down to that thing. All right, so zeros at 0, -1, 2, 3, 4, 5, 6, and then 1. Okay, I got the point -3, -108, so -1, 2, 3, and then -108. Well, there's -100, so -108 is going to be closer to that, -110, like that. And then I have the point 1/2, -13/16. So 1/2, and then -13/16 is just going to be like right. It's going to be like the tiniest little drop down there. And behaviors, as Caitlin pointed out, right, they're both going to go to positive infinity. So as I go to my furthest right point here, as x goes to infinity, so as I go further right from my furthest right 0, I'm going to go up to infinity. So it's got to go up. And as I go further and further to the left, as x approaches -infinity, I'm going to go further up. Like that. So we're going to kind of go down, and then we just connect the dots. Connect the dots. Okay, like so. And there's our graph. Questions on any of that? Any questions? Too easy. All right, well, here, let me give you 2 to try. We'll go over those 2, and then we'll get started on the homework. Okay, because that's it. That's all I was going to do. So I'm going to give you 2 here to try. Give you 2 to try. All right. So here's for y'all. These are for y'all right here. Okay. And I have graph paper too. If you want to use graph paper for some of these, I don't know. Okay. So the first one I'm going to give you is y equals -x plus 3 times x minus 1 times x plus 5. Okay, just like that. So graph. And then number 2, again, just 2 of these. Y equals x cubed minus 3x squared minus 4x. So there's 2 for you. Again, just sketch the graph, right? Come up with all the little pieces that we normally use to sketch that graph. And don't look at your calculator until after you've done it. Okay? Don't use your calculator until after you've done it. Because this could show up on a non-calculator section, right? Most likely it would, because otherwise this would kind of be trivial with a calculator. Okay, so more than likely this will be a non-calculator question. Make sure you put your zeros in order, numeric order, before you start trying to find the middle behavior points. Okay, okay. Right, doesn't have to be the midpoint.
It's all about preference. Left the equation out and then plugged in the 2 midpoints and 0. Just makes the numbers good. Oh, I thought it was negative x plus 3, not.
Yeah. No, but it shouldn't. Oh, it will. It will change things. Yes. Sorry. Yes, folks. Sorry. The way I read things there. Be careful. Okay. Yeah. I realized that as I was saying it. So number 1, it's a negative, and then the quantity x plus 3, x minus 1, x plus 5. Yeah. So if you just wrote if you just put negative x plus 3, that would change things. Yeah. So it's a negative in front of the parentheses there, then the x plus 3, x minus 1, x plus 5. Okay. It will be different. Very, very good. Yes, Morgan, question? No, you wouldn't. You would only want to distribute to like one of them if you wanted to. If you would distribute it, you can pick the first one if you want. Yeah. Right, because I mean, think about it. Think about what you got here. Basically, is this.
Well, the first one would change because I had it as
I mean, you have something like this. So the negative would only go with one of these, right?
It would be negative.
Like you don't distribute to all 3 of them. It's like
It's originally
this one, or this.
positive 3, now it'll be negative.
Doesn't matter.
But the numbers in between, finding that one different.
Really good. Our diligence is value as a negative 4.
find the middles, middle of them,
Uh-huh.
to put it back into the factored equation, do you have to add that negative in front?
The negative is there, yep. Mm-hmm. So you'll multiply by a negative in the end, kind of thing, yep.
So the leading coefficient would be what, negative x?
Yeah, that stays the same. Wait, why?
It'd be negative 1.
Yeah.
Sorry.
You could do this actually.
If you really finish yourself up, what you do. When did you get 16?
Okay.
clarification.
Alright, so hopefully we're done at least the first one there. So there's number 1. Kind of take a look at that one. Again, you can choose any kind of, x value for that middle behavior that's obviously in the interval there. So for example, here between the 0 of 1 and -3, right, you can pick any x value between those 2 points, between those 2 zeros, to help you figure out what the middle behavior is going to be. All right, whichever one you choose, you need to show your calculations. All right, you can't just kind of guess where it's going to be. You should show your calculations for it. Okay, I would pick the midpoint again, just because it gives, I feel like, the best kind of guide as far as what the graph will look like, but it's not exactly the maximum point or minimum point, whatever it is. Okay. So yeah, you can pick any point you want between those 2 zeros. I like to pick the midpoint. You don't have to. There it is. No double roots here, so it kind of follows the very typical, down, up, kind of alternating behavior there, I guess I'll say. No surprise. Any questions on that first one? All good there? Right. And then I'll go ahead and put up here the second one as well. Might as well, right? I guess I'll just try and squeeze them both off. They kind of both fit. Alright, so one of the middle behavior points you couldn't avoid using fractions, right? Because you got to pick some number between 0 and -1, and that means you got to pick a fraction. So I chose the -1/2, and just calculated from there. I got 9/8. And when I do my substitutions, again, I substitute back into the factored form. I find that's easier to calculate. Substituting back into the factored form and then evaluating from there. It's up to you how you want to do it there. Again, just be careful, right? Especially a mistake in the factoring can really throw off your graph. Okay, it can really throw your graph off. So try to be careful with that. On the test, You know, I will try to be merciful in that regard. If you make, you know, an error in like your factoring, it kind of throws everything else off. Well, not everything, but quite a few things off. So I'll try to, you know, give some partial credit and stuff like that where I can. So this test can take me some time to grade sometimes. There's lots of mistakes. So hopefully no one will make mistakes. It'll be easy and quick to grade. Question? Yeah. Nope. You can change whatever scale you want. Yeah. There will be like a actually, I think there is. I think there's graph provided, or it may just be open space. I forget now. Let's take a look and see. So, you know. Anyways. Okay. Questions on any of that? All right, folks. So let me give you guys our assignment then. Okay, if you need to see this, let me know. I'll put it back up for you and stuff like that too. But otherwise, okay, you're going to have 4 of these for your homework. So page 146, numbers 75, 81, 84, and 85. If you want to start, yes, you may. So I just want your down to the answer. First 2 questions are inequality questions. You don't have to do them, but if you do, I will grade them. They just won't count for or against you. Okay. And then the other questions And so again, folks, I will be collecting your homework on Monday. Okay, the homework for this week, including this assignment here, will be collected Monday. That's done.
I was so infuriated. I stayed like an extra 2 hours. What we were doing. What ended up happening? Nothing. No, we sat. We're sitting on the couch. It was like a house party. We're sitting on the couch watching. And I was really me. So I had like my arm. Luke wanted to be filled in.
I've seen how you do more control emotions in the last 10 minutes than I think I ever have.
You ever need to show you.
Question.
But she doesn't.
I have my own book.
Thank you, Abby, for grading the warm-up. Appreciate it.
Actually, I think I was thinking that would probably be
Oh. I think I need to stop for this.